Lovely. So welcome back. I hope you had a very nice lunch break. I hope nobody of you is in food coma because we're gonna need your attention to follow this amazing talk about understanding transaction isolation for app developers by Chandra, who's a solution architect in AWS. So I'm going to hand this over to you and good luck.
Sure, thank you. So good afternoon, everyone, and thank you so much for this opportunity. And special thanks to all the speakers because these are all great sessions, and this is really a great learning for us today. And in this session, the session today is understanding the transaction isolation levels for the app developers. So I know this is after the lunch, and I want to make this a bit interactive. So just imagine that you are sitting in a movie theater watching a movie-based application. So this application is made for managing the transactions for the movies. That includes how to buy the tickets and how to set the prices and running the reports and such so. So I will be showing only 3 slides, and I will be repeating this only 3 slides throughout the session. Okay? And why this is important to understand this isolation levels, especially for the app developers, not only for the app developers. This is so important for the database developers and the designers and the architects and including the database administrators is if we have this knowledge of this isolation levels, then we can fix certain anomalies in your application during the design and the coding phase. So that's a major benefit of why we need to have this knowledge on the isolation levels. Okay. And before heading on to the agenda, a quick introduction about myself. As she introduced, my name is Chandra Pathivada, and I am the database specialist solution architect from Amazon Web Services, with the primary area of focus is on Postgres. That includes Postgres on RDS and Postgres on Aurora, and Babelfish for Aurora. So, and I have around 15 years of experience in SQL Server, with recent 10 years of experience in the Postgres. So if anyone has any questions, like if you have a workload to migrate from SQL Server to the Postgres, especially using the Babelfish, which is a new service released by the AWS in last year, then you can reach out to me. I'll be available outside, after this session at the booth. So, yeah. So with that said, let's get started with this agenda. So the way how I structure this agenda is first we will go through the application behaviors in terms of certain anomalies in these behaviors. And we will fix these anomalies by understanding these isolation levels, and we will fix these 3 behaviors in the following slides. And we will conclude these presentations by applying the best practices, right? But I know like most of the guys are well aware of MVCC in the Postgres, but for the folks who are pretty new to the Postgres, I just want to give a very high-level overview on what this MVCC is, because this MVCC is a prerequisite to understand the rest of the slides. So what is MVCC? MVCC is a multi-version concurrency control, because the way how Postgres manages the concurrency is to creating the multiple versions of the same record during the update statement. So on the right-hand side, you see a table record, and let's assume that there is a table which has only one row and one column with only one value, which is the record A. Okay, and the structure of the record looks like this. So every record has a data portion that includes the data what you entered into the record, and a header section. And the header section contains several columns that includes xmin, xmax, and along with few more other columns. And it also contains some information that's called hint bytes. I'll cover what is in hint bytes a little bit later. But if you look into this record, I just inserted a record. Let's assume that I inserted a record with only one value A. So when I insert this record, then the transaction which is inserting the record, it contains a transaction ID. And the transaction ID 201 will be fed into the xmin column over here along with the data. And the xmax won't be having anything. So you can make it like what are all the records that are inserted into these tables without getting updated. So you can make it by checking the xmax is equal to null. If the xmax doesn't contain any data, that means it's a new data. Okay? And let's assume that I'm updating this record A to A1. Okay? So in Postgres, when you update a record, then what it does is, first it inserts a record. It inserts a new record, and then it updates the existing record like as a deleted tuple. And then it marks the existing record like as a deleted tuple. So it's a logical delete. There is no physical delete in the Postgres. Okay. So, and let's assume my update statement or my update transaction, when I update it, the new inserted record contains the transaction ID 230 will be in this new one, and the same transaction ID will be get updated in the existing Xmax column. Okay. Yeah. Sorry. Okay. So let's assume that I'm still updating this record, and this record is still in an open transaction and it hasn't yet committed yet. Okay. And the way how Postgres knows whether this record or the transaction is committed or not is by looking at the clock area, or it can also get this information from the hint bytes in the header section on each and every row. So let's assume that this transaction is not yet committed. And if it is not yet committed, then if another user is trying to access this record, if he is using a select statement, then he won't be get blocked. Why? Because that user can get the information from the recently committed data, which is the 201, with the xmin 201, which is the record A. So in this way, in Postgres, you don't see any blocking. Like in Postgres, writers won't block the readers and the readers won't block the writers. But this kind of a behavior, especially for the people who are coming with the SQL Server background, then they may see this kind of a behavior in the read committed isolation level, because the SQL Server is not in MVCC mode. Okay. So the writers won't block readers and the readers won't block writers. And the next one is, every time when you execute a select statement, okay, especially if it is in a read committed isolation level, which is the by default isolation level, every time when you execute a select statement, it takes a snapshot view of your database. It's not the snapshot backup. It is a snapshot view of the database that contains all the records which should get it onto this select statement. And the way how it gets this snapshot view is based on the visibility rules in the Postgres. There are a lot of visibility rules in the Postgres, and these visibility rules primarily depends on what action you are doing and what isolation level you are applying on and at what level. So based on this visibility rules, the select statement will obtain the snapshot view of the database and present it to the select statement, to that particular transaction. Okay. So in a read committed isolation level, if you are executing multiple statements, if you look at here, the same table I am executing multiple times, select star from TVL, I'm executing 3 times. So every time I execute the statement in the read committed isolation level, it obtains a new snapshot. Okay. So in between this select statement, if another user changes the record set, then you obtains the latest view of the data between these select statements, even if it is in a single begin transaction in the read committed isolation level. Okay. But if you are using repeatable red or the serialization isolation level, then what it does is it obtains the snapshot view of the database only at the beginning of the transaction. In case of the repeatable red, it obtains the snapshot during the first select statement within a transaction. And in case of the serializable isolation level, it obtains the first snapshot during the begin command. So when it obtains a snapshot only at the beginning of this block, then this snapshot remains same. So even if another users are changing the data, then this data won't be get changed. And you get a consistent snapshot view across all this select statement in repeatable red and the serializable isolation levels. Okay. So this is the background of MVCC. Now let's head on to our behaviors, the examples. Okay. And let's assume that I'm the owner of this multiplex theater. Let's assume that you are sitting in a theater and I'm the owner of this theater. And now I'm seeing what are all the tickets prices for all my screens. Okay. And here you see the 2D, 4D, IMAX and the premium, multiple theaters. And I see like for my IMAX theater, it is $10 and I want to increase the price by adding $5 more. Okay. And then I asked my staff members to increase the price to $5 more. Then two of my staff members logged in at the same time, and they both executed the select statement in the read committed isolation level, and they both have seen the $10 for the IMAX. And the first user updated the statement, okay? He made a statement by adding the price to $5, like update table name set price is equal to price plus $5, where screen is equal to IMAX. Then he should get $15, right? Right. But what happens is the second user is also updating the same transaction by increasing the price to the $5, but instead showing the $15, it is showing $20. Okay? He's seeing the $10 and he added $5, but he has seen $20. Why? Because during the middle of the transaction, another user already updated this record. Okay? So why this is so important to understand this anomaly? Okay? So as an application developer, if we know this behavior using the default isolation level, then we can also change the statement by setting update my table set price is equal to $15. Instead setting set price is equal to price plus $5. So if I set it to the target price, even if multiple users are updating the same statement, even if multiple staff members are updating the price at the same statement, they still see only the $15. Okay? So, I mean, this behaviors will help to foresee what kind of anomalies that we could face when developing the application once it goes online, and particularly when the application has multiple concurrent users, and we can rewrite our code to reduce this. Okay? And this is a, yes?
That was a scenario for isolation level read committed.
Read committed, yeah. So I'll be showing the three examples, the first three examples, and all these three examples, the behavior is the default isolation level, which is the read committed. Thank you. Yeah. So this is a sample dashboard report. You don't need to look into the numbers and the content. I know this is not even visible, but I just want to show you this as an example. Like sometimes we create a dashboard report like this, where we fill each and every cell with multiple select queries, especially if it is a financial-based application or the dashboard kind of a report application. And let's assume as an owner of this theater, I want to know how many tickets got sold. So right now, I just write in select statement, select start from ticket sales, and I see 10 records, okay? And then I ran another statement. I just want to see the total sum, and I see $100 for 10 records, where each record is $10. And next time when I execute the count star, then it is showing 11. So in the first select statement, it is showing 10, and in the next select statement, it is showing the 11. And again, when I ran the set sum of price, it is showing a different price, which is $108, right? So this is inconsistent between the multiple select statements, right? So why this happened is because another user just bought a ticket, so he inserted a new record, and he also updated an existing record, and that change got reflected as okay, that change got reflected, and that is the reason user A sees different set of results between the executions. And why this happens is because in the read committed isolation level, every time when you execute a select statement, it obtains a new snapshot view of the data. So that is the reason he sees a new snapshot view and he sees this difference. Okay? So this anomaly is called a non-repeatable red, especially if you are running the reports, especially if it is in financial based reports or in dashboard kind of a reports with multiple select statements in between, then this is one such thing that you should be aware of. Okay? And let's have a look into this in another anomaly called the serialization anomaly. Okay? Let's assume two users went to a theater and they both want to buy the tickets, and they want to see how many tickets left. And then in the dashboard, it is showing only 2 tickets left, because the query is select 100 minus count star. So let's assume that the total seating capacity for the theater is only 100 seats, and 98 tickets got sold, so only 2 seats are left. So they both are saying only 2 tickets, I mean the 2 seats are left for that particular theater, right? So, I'm sorry. Okay. So one user bought the tickets. No, he bought both the tickets, and he sees 0, that means it's completely got sold. And then another user also bought the 2 tickets, and he sees the 0, that means all the tickets got sold. But what happens is when we look into the final result, it is a negative 2. That means we actually sold 4 tickets, though only 2 seats are available. So even if a guy got the 2 tickets, he won't get a seat, though he enters into the theater. Okay. So this, but but what if we executes these statements one at a time, like in a serial manner? So first check how many seats are available, and then buy the tickets, and then check the balance. The balance will be 0. Then he cannot buy anything. So the next user won't buy the new tickets, right? So if it happens in a serializable manner, then they won't see this anomaly. But because of the concurrency, it allows both the user to buy the tickets. So that's the reason they are seeing this anomaly. And this anomaly is called a serialization anomaly. Okay? So let's review all these things together. Okay, the last updates. 2 users are reading the same data, and when they both update the same row, then the first user lost his values because it's got overridden by the next user. Okay, and the non-repeatable rates, the dashboard reports. So a transaction rereads the same data, but it finds different values because then another user updated the same thing. Okay. In the serialization anomaly, the final results come from the concurrent transactions must be equivalent to a result that could have occurred if there is only one transaction that executes in a serializable manner. Okay? So this is a quick review of the anomalies what we have seen in the previous 3 slides. And now let's fix these anomalies by applying the isolation levels. Okay? So in Postgres, we can see 3 isolation levels, which are read committed, repeatable red, and serializable isolation level. Okay. In Postgres, there is one more isolation level called the read uncommitted. But even if you apply the read uncommitted, it behaves exactly like as a read committed isolation level. Why? Because in Postgres, the dirty reads are not allowed because it's not needed because of the MVCC. Dirty read means reading the uncommitted data. Okay. So the people who are coming from the SQL Server background, then they usually applies the read uncommitted isolation levels because that is the only way to get away from the blocking, but they get the dirty data. But in the Postgres, it's not possible. Okay. So in the Postgres, along these 3 isolation levels, the read committed isolation level, when using this read committed isolation level, all these anomalies are possible. This is what we have seen in the previous 3 slides. Okay? But in the serializable isolation levels, none of these anomalies are possible. But in the repeatable red, only the last updates and the phantom reads are not possible. But the serialization anomaly is still possible in the repeatable red. Okay? Now, if you look at the definition, the read committed isolation level. See, one thing about the read committed isolation level is when you are executing a select statement, it gets a consistent snapshot view of the database. It is a consistent snapshot. That means, let's assume that you are running a select statement on a 10 million rows. So while it is executing to get all these 10 million rows in one single select statement, in between when someone changes any record, then he won't see that record because this is a consistent snapshot view. Okay? So that's how the read committed isolation level works. And as I mentioned in the previous slide, like in the read committed isolation level, every time when you execute a select statement and the subsequent select statements within a begin transaction, it obtains a new snapshot view. Okay, but that introduces these 3 anomalies. Okay, but in the repeatable red isolation level, which is strongly recommended if you are running any dashboard reports by executing the select statements on the table multiple times. Okay, because here you won't see the non-repeatable red anomaly or neither the phantom red nor the last updates. Why? Because it obtains the snapshot during the first select statement after the beginning of the transaction. Okay? And the second thing is the way how internally this repeatable rate works is internally the Postgres will call a function. The function is called exec update. The exec update function it calls, and the function will check what kind of transaction is happening in this database and what isolation level and on what object and what users are doing at what action. And it checks based on this incoming transaction, and if there is anything that is violating the rules of these lost updates, like two users are reading the same data, but both the users are updating the same data. If you look at the first example, both the users are looking at the the prices, the movie theater prices, and both are updating the price to the $15, right? So in the repeatable red isolation level, you don't see the last update. That means if user A executes, then if he commits, and at the same time, if the user 2 also executes and if he commits, then it aborts the user 2 transaction, and it will make sure only one user committed the transaction if two concurrent users are trying to update the same record. That you will see in the next example as well. Okay, and in the serializable isolation level, okay, this avoids the lost updates and the repeatable rates and also the serialization anomalies. Okay, because the serialization isolation level also obtains a snapshot view of the database at the beginning of this transaction. So in that way, it can avoid the repeatable red isolation level. The repeatable non-repeatable red anomaly, and the way how it handles the serialization anomaly is internally it executes a function called check target for conflicts. So the function check target for conflicts, what it does is it creates a special type of logs called the predicate logs. And the predicate logs contains all the information about who is accessing what object by using what isolation level and what action he is doing. Okay. So let's say if a user A is accessing a table and he's doing an index scan or a heap scan, and if another user is trying to update, or when both the users are inserting the data based on what they are reading, okay, and the moment if it detects the concurrent transactions, which is where anywhere if it is violating the any of these anomalies, especially the serialization anomaly, then it aborts the last committed transaction. Okay, so in that way it handles these anomalies in the serialization isolation level. Okay, so now I will be repeating the first 3 slides, but here I will be applying an appropriate isolation levels to fix these anomalies. So now the same thing. Now I'm the owner of this theater. Now I see the $10 and $10 and I want to update it. And 2 of my staff members, they both logged in at the same time. And one staff member, they increase the price to $5. And at the same time, when another user trying to update the same statement, then it aborts the transaction. Okay, and this happens in the repeatable red isolation level because both are accessing this using the repeatable red isolation level. Okay, so when the second user, even if he tries to commit, then the result what he sees is a rollback. So it rollbacks the second user transaction. So especially when you are using the repeatable red or the serializable isolation level, make sure that you prepare your application to retrace the transactions, because you see some kind of transaction failures, because using these isolation levels you see some transaction failures as and when it violates these rules. Okay, and the second example, okay, so in the last he also sees the $15. Okay. Okay. And now the second example, the non-repeatable rates. First I'm saying this is the repeatable red isolation level transaction. Now there are 10 tickets and I did a ticket sum of price, okay, which is $100. And after that another user inserted a record and updated a record. And this user, the first user run the count, but he still sees the 10 records and he still sees the total sum is $100. So the values never get changed during the multiple subsequent execution of the select statement, though when another user is changing the data. Why it happens? It's because it obtains snapshots during the beginning of the transaction. In that way, it avoids these repeatable writes. Okay. And the third example, the same example. 2 seats are left. 2 users are trying to buy both the seats. Okay. But This transaction, I begin with a serializable isolation level. So the first user bought the tickets. So when we bought the tickets, we insert 2 records. And the second user bought the 2 tickets. Okay, so we inserted 2 records. And when the first user committed, he got 2 tickets. And when the second user committed, then his transaction got aborted. Okay, so even if he commits this transaction, it will be rolled back. So in this way, we can avoid this. Okay? Yeah. So the ticket left is still 0 because the second transaction got aborted. Okay? So the best practices are know aware of these anomalies and design your application, as I mentioned in the beginning. And when using the repeatable red isolation level, specifically if you are using like as a Tableau or the QuickSight or such kind of and reporting applications, you can simply specify that application connection as in read only. In that way, especially when using the repeatable red, in that way you don't see the failures because using the same connection you cannot update it, right? And limit the number of connections using the serializable transactions because the more the concurrency, you get less the less consistency. If you want to achieve more consistency, then that leads to the less concurrency. So if you increase the more concurrent transactions when using the serializable isolation levels especially, then you see lot of connection aborts. Okay? So when using the serializable isolation levels, make sure like no, for certain operations, like say the PG dump uses the serializable isolation levels because it only reads the data and it won't update the data, right? So if you're doing any such kind of operations and predicting like, that you need a kind of a serializable thing, then you can apply the serialization isolation level, or else since it's a very strict isolation levels, don't use the serialization isolation levels. Instead, design your application in such a way like, without using this isolation level, you should still can achieve some kind of concurrency. Okay. And and don't open the connections, and you can set a parameter idle in transaction session timeout to a certain value so that it won't open the connections over a period of time. And the fifth one is when using the serialization isolation level, make sure that the table has a primary key or an unique index. Why? Because if the table is purely a heap table without having any primary key, then what it does is it locks each and every row in that table, and then it applies a table lock. So even if you are updating one row, it still locks the rest of all the rows, and there you see the more blocking. Okay. So pay attention to that when using the serialization isolation level and follow the best practices. Okay. So with that, that leads to the end of the session, and thank you so much for this opportunity, and special thanks to the PG conference for arranging such wonderful sessions, and thanks again.